Side observations of the weather last week. I wanted to look at two. First of all, there was a couple Colorado snowstorms that I thought were quite interesting. This one here is the Tuesday Colorado snowstorm. There was also a Colorado snowstorm on Sunday night, which kind of bombed. It was forecast to be much bigger than it was, and it only turned out to be a couple of inches. This one turned out to be 5 or 6 inches, and many of you have heard that people actually got sent home to Colorado because of this storm. And I know my son who works in Denver got sent home too because the snow was not so heavy. It was 5 or 6 inches, but the wind was amazing. And normally with snowstorms in Colorado, you don't get a lot of wind, but sometimes you do. And this one was a particular one. This is the radar, and what you can see on the radar is almost like a vortex that forms over here near just between Denver and Boulder. I thought that was quite interesting, so I thought I'd do a numerical simulation to see if that's actually robust. And by robust, I mean, does it actually show up in a numerical simulation? And the animate, this is a numerical simulation for the entire day. The colors on here are the radar, and the blue-green is the color of the 281 theta surface. So you could think of this as being the front that's kind of parked up against the front range. And it's really interesting when fronts come through in Colorado. Quite often you have high terrain over here, you have high terrain in the middle, and the fronts tend to go around the high terrain and then swing in from the east. So whereas if there wasn't the terrain there, the fronts would just sweep down from the north. They quite often come in from the east and around this way, like you see here. Now, what you're seeing in here in the morning when we saw that radar is there's also a vortex forming here. And it appears this vortex is a result of southerly flow coming up here and flow swinging in from the east. And together, they're forming a vortex sheet, which is rolling up on the front range over here. And this is responsible for their winds.
What were the winds like? Do you know the speeds roughly?
No, I don't know the speeds. They were strong. They were drifting the snow.
Wow.
And that's why everybody was sent home.
Hmm.
So interesting situation.
Yeah.
I won't dwell on this one anymore.
So when you selected the 281K surface,
Yeah.
it doesn't seem like it really gets all the way to the front range itself. Is that?
Yeah, you can get different ones.
Right.
I didn't want to cover my lines.
I see. Yeah. Makes
So,
sense.
but yeah, they're actually quite spectacular. You see this many times. I know in Fort Collins here, we would look at these things coming up against the front range, and as these things would sit here, you'd actually see the slope, like you draw on a cross section, you'd actually see that in front of you. And they're quite spectacular. And the reason you can see the slope is because the visibility is markedly changed inside the cold air, because you get more wet haze and things like that. So and the light is refracted a little different. So you can actually see this blue wedge sitting against the mountains, and it's pretty spectacular. So we go on to the next one, if it'll come up. And
As you're clicking, how much snow did your model produce for that area?
how much does it what?
Did it produce for that event, your simulation, roughly?
I didn't look. I think it was 5 or 6 inches.
Okay, so
like
it's
I
kind of
said.
consistent.
Yeah. So I want to do a California one. This California one, many of you who are on the map site have seen. There's a lot of discussion going back and forth about what's going on with these California storms. And let me see if I can get this up here. I simulated this on 2 grids: a fine grid of 5 kilometers and a coarse grid of 25 kilometers. So I'm trying to get the big situation and the local situation at the same time. It's actually not that easy to do because of the tremendous generation of gravity waves by these mountains. Okay, this is, it looks a little better in reverse. Here is a map where we are. Change the color on that. You can kind of see that. So this is the western U.S. This over here is the 41 meter per second surface of the jet stream. That was over there. And I'm coloring the jet stream by the potential vorticity. So if you see any colors like on the edge right here, this is more tropical type air. There's not much tropical air on the equatorward side of this jet. This is what the jet did. I think it's interesting on this larger scale here to look at the jet. Oh, the topography is shown here. If I tilt it up, I'll give you an idea what the topography is like. So there's a jet stream, there's a topography. This is fairly high resolution topography. And the colors at the surface on the wind speed. So you get an idea where the wind is strong. You got a surge of wind coming off the west coast and these little surges in here. You're not going to be able to see the windstorms in this picture too much, but I think it's interesting to look at the synoptic situation. In particular, what I'm interested in is look what happens to this jet. See it come apart? The jet just dissipates, and I thought, well, maybe the model's doing this. So this is one thing I was struggling with, and I looked at the GFS, and it does exactly the same thing. The jet's making this corner, and we know, for instance, the jet tends to dissipate on the northern side and then reform on the south. It doesn't actually ground the corner, like you might intuitively think. But in this case here, it's really dissipating on the western side, and this, in some of the simulations I was battling with, found that this has a lot to do with gravity waves that are forming on the equatorward side of the jet and just tearing it up. But in the meantime, you see these wind surges spreading out in California down here. So let's go to this fine grid and look at this a little bit, and then I'll be done.
You gotta move the muscle here.
Takes a minute to get this started, but it's still quicker than trying to recreate all the surfaces again. So I thought this was quite interesting. Have any of you looked at the map site that been talking about this?
I've seen a lot of talk about the fires. Yeah, Dale Duran's.
Well, I mean, yeah, Dale Duran, but they've been
Yeah.
talking about the kinds of what's causing these windstorms.
Yeah.
Telling you about this. Are these windstorms a surge or what? And let's just look at this from the top first. This is looking at the windstorms from the top. Again, I'm coloring the surface by the wind speed. And let me get you a perspective here. Certain parts of this don't seem to save when you do a save on it.
It's because it's like a 4 gigabyte file or something, isn't it?
Yeah.
I think it mainly just saves commands to regenerate them automatically. There's like TCL commands that it saves.
So this is the day of Wednesday, which I think is when you have the real high wind speeds. I don't think the model at 5 kilometers resolution is not producing real high wind speeds, but you can see these plumes forming in various places along the canyon over here. High winds.
This is just velocity?
This is just the speed. Yeah.
Okay.
Yeah.
Wow, that's awesome.
And you could get a perspective of where that jet stream was.
Jet comes out of the bay more than once.
And there's the jet stream. You can see more distinctly on here how it kind of breaks up with these gravity waves, but I don't believe it's the gravity waves that are affecting the windstorms exactly. The vectors.
This is strongly anticyclonically curved part of the jet. So is there just big anticyclogenesis in southern
Well, that's
Nevada?
isn't it cyclonically curved, Jeff? 'Cause
Well, yeah, but I guess I meant to say you're right, but I meant to say you're on the upstream side of the trough, upstream side of it. So over southern Nevada, there's probably anticyclogenesis going on, and does that have something to do with forcing all this flow through the gaps?
well, as it turns out, it's not forcing all the flow through the gap like I thought yesterday.
Okay.
And that's what I wanted to look at. See, you can see these winds spreading out here coming
Yeah,
out.
and they're long-lived. That's another thing that makes me think it can't just be that.
It's hard to put it's hard to put the streamlines on there to show the winds because topography changes so much. And this 5D only does it.
That's a jet that's racing up the coast of California, northward.
You know, what is that? I think you can see that it's some kind of a trapped, maybe like a Kelvin wave. You see how it's trapped against the coast?
Yeah.
And it's surging up?
They have
I don't know what it is.
the marine air in the summertime does that. You can see it happen along the west coast. I don't know what it is at this time of year.
But surging north, I think of those, well,
Like a heat low that kind
no,
of keeps going up
the
the coast,
Kelvin
you know?
waves surge north.
Yeah,
don't they?
yeah,
Oh, that's
So that's probably a Kelvin wave.
yeah.
What are those wind speeds in red? What is the value of the speed?
Gotta find the actual. It goes from 0 to 68 meters per second.
So the
But
reds are-
that's not there.
So those are
The
probably
red
like
is, the
15
red
to
is way
20.
down here. It's about 15, 20
Yeah.
meters per
So that's
second.
still what, 40 meters for the surface.
Yeah. So that's what's happening. But I think the interesting part of this is to look at these cross sections that I initially had up there. The W, and I have a cross section like this in W. Let's take the jet stream off and no. Streamline off, okay. Now you can see all the gravity waves up against the mountains there, right? And what I found very fascinating is you see there's two scales of gravity waves that are superimposed on top of each other. You've got these big ones over here that are traveling very high. You see how they're up and down and they're getting up to the jet stream level. Those are what are tearing up the jet, those big ones that are moving up. But on the other hand, you got all these little ones down here, and these little ones are associated with the surge. Okay, these are what are associated with that low-level wind that's surging out at the bottom. And they're also gravity waves. They're also associated with the peak. See how this is red going up and then blue going down on this side, and this is where the waves are. But here's the cool thing. If you look at theta, here's the potential temperature. Look at what you have. You have a stable layer right in here, and they're trapped underneath that.
Mhm.
That's a critical layer. And so what's happening is the critical layer is impervious to allowing short gravity waves to travel vertically. The mountains are composed of all different wavelengths of gravity waves. There's long waves and short waves, all part of that rough topography. But the short ones are being trapped, what's showing here, and those trapped ones are ducted down to low levels and producing the windstorms. So it's this inversion that's doing it. This is what Dale Duran was talking about in his little spiel this morning on that. So that just gives you an idea of what's actually related to these things. And so they are really gravity waves. They're not surges through gaps. They're a flow going over the mountain and down the other side and accelerated by a positive reinforcement because of the ducting. And sometimes there's an over-reflection if there's a little instability in there. I don't know if that's occurring now. By over-reflection, it means they reflect off the layer with more energy than they approach it. Yeah.
Do you want to mention what gravity waves are?
What are gravity waves?
Yeah, for
If you throw a pebble in a pond, the waves are going to like that. And in the atmosphere, you have internal gravity waves. The things you see on the pond are external gravity waves. They're resulting from the higher density of the water versus the air. But in the atmosphere, you have increasing density as you go up. And so in the atmosphere, you have internal waves that tend to propagate vertically. And what you're seeing here is these waves are tilted with height back toward the east, right? You see how these waves, as you look up higher, they don't just go straight up. They go up with a tilt. Where they're tilted with height, they're transferring energy, actually, and transferring momentum downward and energy upward. It's the tilt that does it. The waves down here, the low-level ones, are much less tilted with height. That's because they're being trapped underneath this inversion layer, or critical layer, let's call it. The critical layer, by trapping the waves, forces the phase lines to be more vertical. These waves are kind of changing slope, which means the transmissivity of the atmosphere is changing with height. It's not just constant. It's slanted more in some places than others.
So is this stable layer that you see there, or how high up it is that a characteristic of the Santa Ana events?
Apparently.
I would guess
I
that it
didn't
is.
realize that. I knew they were different, but I didn't know how they were different.
Right. There's,
This is not entirely different from the ones in Boulder or the Rockies.
okay.
Because the Rockies also have stable layers. When you have cold air sitting over the Great Basin, and then you have cold air Arctic system sitting up against the mountains to the east, that's a prime situation for Boulder type snows.
Yeah,
storms too.
so you manufacture that stable layer in a different way than you do here in the Santa
Yeah.
Ana regime, because here it's just gentle subsidence for a period of days with the big ridge
Right.
over the west coast. That's enough to produce that cap.
Right.
And so couple it with record cold in the Intermountain West that filtered into these valleys, it's impossible to get rid of that cap
Right.
in this
So-
situation.
Right, and that record cold, I guess, there were temperatures, I guess, both in LA and San Francisco that I think were in the low 40s.
Probably right. I know Salt Lake was almost as cold as ever for this time of year.
And there's a place in Utah that got down to minus 46 yesterday Fahrenheit.
What? That's
It was in a
unbelievable.
valley, it's an elevated valley.
Wow, unbelievable.
Yeah, it's,
Yeah, so I think there's a synoptic scale setup that enhances this thing that you're telling us about.
yeah.
That probably always comes in one degree or another, and this one might be an exceptionally strong version of it. But it's related to all the large scale features that are around it.
Absolutely. In my previous understanding of this, I thought that what was causing Santa Ana winds is when you have a ridge and you actually get easterly flow
Through the gaps.
through the gaps.
Yeah, that's not
This
here.
is more like northerly flow, so it is coming across the mountains that are oriented more east-west. But they're still mountain waves nevertheless, and they're with more
Yeah.
northerly flow.
And is it marine air out over the ocean in the
Yeah.
anticyclone that
Well,
keeps
that-
it from going just heading straight to the west?
I think out here, this is the usual marine inversion that you normally get out.
Yeah.
Yeah, but you're getting it all the way up over the mountains. And I think Dale was saying that the height of this inversion is unusually high, so that it goes up to the
Yeah.
peak of the mountains, and that's why so much activity is being trapped underneath it.
That's really interesting. But is there a western edge to it? The extreme, you know what I mean? So how do you explain the northerly jet? Why doesn't the air just, since it's being capped, why doesn't it just to the west? I know it's turned to the right as it tries to do that. And is that the whole answer? As a Kelvin wave?
Or,
I don't know,
so, another thing that's interesting, at the very start of this animation,
you know,
you see that the high stratification extends all the way down to the surface, like right there.
Yeah.
But I'm wondering if you're advecting
it
off
starts
a
in
mixed
0
layer.
Z.
It's 0 Z. Okay, so are you advecting a mixed layer off the west coast? So that's why it deepens to get this
No,
mixed
I think
layer.
it's diurnal cycle. It deepens because it warms up in the afternoon.
How long is this?
Over the
This is
ocean.
one day. This is 24 hours.
It never comes back, it seems, at the very end.
You're talking about way on the left over the
well,
ocean.
Yeah, on the
I don't-
far
I mean, it's probably a combination. It's probably enhanced by the.
Really interesting. That's very interesting.
Wow.
That's really cool.
Anyway, okay.
All right.
Thanks, Greg.
Well, thank you, Greg. See, this is the great thing about being in Wisconsin. Somebody like Greg Tripley says, I saw some interesting in the weather this week. I think I want mesoscale models of them and at exceptionally high resolution, and we'll learn brand new things about the way it works. And it happens almost in real time. I don't think that happens in most places around the country, but it does here, so pretty remarkable. Well, that's really neat. So this will be fairly abbreviated as they go, because we don't want to keep it too late.
You steal your seat.
Yeah, go right ahead. So let's start with for the current one, though, let's look at our current satellite movie. Everybody knows we had a spectacularly exciting week this week. We broke the all-time October snowfall record for the month of October in Madison by a mile. I think the old record was 5.2. It seemed to be either 5 or 5.2. I'll go with 5.2. And then, even though we were shortchanged, certainly shortchanged at the airport yesterday for our total, there was nobody I know who had only 3.9 inches of snow in their house yesterday in Madison. It was more like 5 or 6. Huh?
That's what the airport reported.
Yeah, 3.9, which,
Yesterday?
yeah, it's almost, I don't know how to describe it. Every time you get an inch here in town, and then the airport reports 5, and then when everybody else gets 5, the airport reports 3.9. So even with what I think is clearly an underrepresented snowfall at the airport yesterday, we still had 8.2 for this month. And I think it was closer to 10. So it was a shattering of the old record, absolute shattering of it. The other thing that was interesting was in class yesterday, I think it was Andrew Quigley, or it might have been Josh, who said we got the all-time earliest 4-inch or more snowfall, anticipating that we were going to get over 3.9. We didn't. So for a single event, we did for sure. We got 5 point something for a single event, but it wasn't in the one day. So the prior earliest such snowfall, 4-inch or more, was November 3rd of, I don't know, it was 1926 or something. So we're at the wall. We're on the asymptote, I think. We can't go any further than we have. And we just barely were able to push it. It's like the guy who just ran an under 2-hour marathon. No one's going to do under an hour and 50 minutes for 150 years. It's not going to happen. So anyway, here's the cyclone that developed in response to the whole big upper trough, part of which Greg was just showing us over the western United States. For a very long time, that was a positively tilted trough with just straight southwesterly flow on the other side, a local curvature maxima at its base, and that gradually over time, yesterday it got to about a neutral tilt, and then it's taken on a negative tilt today. I think we'll see that in the super repeats. And the wavelength kept getting smaller too, with the tilt getting smaller. I don't know if there's any reason why they went together that way, except maybe just this case. But right now, it's a robust shortwave disturbance, and it's producing a really intense cyclone over the northeast part of North America. Heavy snows in central Quebec, and some pretty heavy rains along the east coast earlier in the week, I guess yesterday evening and tonight.
Right, it's severe weather was a squall line that developed.
Oh, yeah, that's
yesterday.
right. That's right.
I think there was some rotation indicated Albany area, at least in eastern
Oh, is
New York
that right?
State, the surface street cells were trying to develop.
Yeah, and there was widespread tornado watches over the east coast yesterday. It wasn't just county by county, it was really widespread. So this is a potent storm, and it developed rather quickly of a long wave evolution. The flow, remember last Friday we were talking about how wavy the flow was, and this is maybe the last of the major waves in that flow, and it's turning into a really intense cyclone as we speak. So let's take a look at the radar across the continental United States with good people. So boring for the first day all week over the central part of the United States, and most of the activity, as you saw on satellite, is offshore or in southern Canada, and Canada doesn't contribute to this mosaic. So we don't see too much except maybe some scattered showers in the cold air over northeastern Maine.
I was going to say, you say this is boring right
Yeah.
now, relative week, but if we had not seen the two events we saw this weekend and just yesterday,
I'd be thrilled that
Thrilled.
it's snowing in southwest Iowa, which we'll look at in a minute. You're right, I'd be absolutely thrilled, and the prospect of some snow showers for us over the whole weekend, both days probably, would thrill me. It still does, don't get me wrong, but it's boring compared to what we just saw. It's like going to a Little League game after Game 7 of the World Series. If you like baseball, you still like it, but it's not the same. So, yeah, this is the interesting feature for our own locale. This is probably all light snow from Omaha, almost Michael's hometown, Lincoln, and then Des Moines, and then heading up to the north and east. We should see a little bit of that later tonight. And then some snow on and off all through the weekend. Michael might say a little bit about that in the forecast. So let's take a look, if we could now, Pete, at the super Petes, which were conspicuously absent in our weather discussion yesterday. I was rather horrified by that. We'll start at 500 millivolts.
Where'd they go?
Well, they were there,
They
but
were used.
our discussants didn't use them. They used other things, but one of the things we had just been talking about in class was the development of upper fronts and the environments that are conducive to that. So here's one that's actually not. We have warm advection and cyclonic shear. That tends to not really help the development of upper fronts. We'll get to that in a minute. Here's our little wave over the eastern United States. Remember what this looked like. Greg even just reminded us with the jet coming around over southern Nevada just a couple of days ago. And now that, as I said, became more and more positive and kind of shrunk back to this smaller wave length. And so now we've got a really sharp cyclonic curvature maxima over western New England, and then a nice anticyclonic portion of the flow over northern Quebec. So the upper divergence is really strong right in the inflection point, and that's where we saw the center of our circulation right now.
Excuse me, John.
Yeah.
Could we look at the animation of that? Just-
Oh, yeah, why not? Let's watch how this works. So here's the wave I'm talking about. And it comes up, and there it is now. So step through that a little more slowly maybe the next time. But you can see the crashing cold air into the west. So that's where we were with Greg. And then here's the trough axis. It's still somewhat positively tilted. Then it's about neutral. It's going to come around the base of this big large wave trough, a long wave trough, sorry. There it is in Kansas. This is our snow day. And then it gets a little bit smaller in wavelength and just kind of rides up and gets more and more negatively tilted so that we get this beautiful upper divergence maxima. It's a really interesting evolution, and one with substantial and sensible weather consequences at the end of the time.
It's interesting is that while the trough axis went by us yesterday, I didn't look carefully at all the details, it didn't seem like we had significant changes in curvature to give us a strong divergence along.
Yeah, no, I think that's right. It was a modest contribution. We dissected this in class yesterday. The discussion was quite good. It was a modest contribution aloft. I think you're right, that since the thing was not really strongly curved flow, we had a little bit of forcing for upward vertical motion coincident with our snowfall. But the main thing was lower tropospheric frontogenesis.
Right.
We may even see that in a couple of these maps when we go to the lower level.
But then I would imagine as the cutoff begins to form, and you see more of a downstream ridge developing, that's when probably transition from just a lower troposphere
Exactly.
forcing to something more deeper. Yeah.
Exactly, and the cloud shield starts to look more characteristic of an extratropical cyclone and all that. But you can still see on the satellite, there's something hanging back to the west, which is probably still the beneficiary of some sort of frontogenetic activity in the lower troposphere. That's how it was for us on that same feature as the storm was taking shape over the southern Great Lakes. Yeah, in fact, we concluded yesterday, or made the statement yesterday after we did the analysis, that when you get weak little snow events, and we're entering the season where we might start to get, 1 every 5 days, it's 1 or 2 inches of snow. That often is a function of the fact that it's either one or the other of those mechanisms that's driving precipitation development. When you get something more substantial like yesterday, that's when you have a concerted effort by two processes as opposed to them acting in isolation. And that's sometimes, that's exactly how I look at the weather maps in the wintertime. Are there two things going on here at once? Or will they be so in the forecast of 24 hours or something? If not, I go home a little bit disappointed. If so, I go home thrilled. And it never goes snow to rain here, so I never worry about that anymore. That's a thing of my past growing up in New England. I never have to worry about it here. I love that. Okay, so let's take a look at, not the evolution, but we'll take a look at the 300 millibar snapshot from this morning. There's 250. Yeah, 250. It's interesting in and of itself because there's more than one jet over the central U.S. this morning. And this, even at 300 millibars, one gets the impression that there's some other maxima to the south over the Red River Valley, and there's one to the north. And then there's this complex over the eastern United States. So we have, at the moment, I've looked at a couple of cross sections through this. You get two distinct jet maximum, one at about 300 millibars, one closer to about 200. And so polar and subtropical jets are near each other, but not vertically superposed in the central United States today. This is an interesting feature to me all the time. Straight jet in north or northwesterly flow, it sometimes leads to the development of a strong upper front and trophiness. This one we just saw at 500 millibars. We go back to 500 feet with all this stuff is quite as interesting. Here in this whole northerly jet streak, there's warm air advection, slight warm advection in cyclonic shear over the prairie provinces of Canada, mountain provinces of Canada, and then Montana. And then maybe there's subtle geostrophic cold advection going on in southeastern Wyoming, maybe northern Colorado. So there'll be a tendency for this trough to get a little bit more accentuated over time. But over here, there'll be a tendency for the ridge to get a little bit more intense. So we're going to have, I think, ridginess growing in the northern portion, trophiness down here, and so that's just going to increase the waviness of the flow. But overall, there'll be large-scale subsidence over this portion, the inflection point on the upstream side. And I think we'll see in the forecast one of a series of anticyclones kind of crashing into the Intermountain West with very high surface pressures in the 1040 range or higher as a consequence of that. So it's a very wintry pattern. There's no doubt about that. It's extremely wintry right now. And this trough will be the first one that we've had in several days that has a really large wavelength. So this is a really long wave trough. And a consequence of that, even though the flow is curved, is that there isn't really any concentrated agiostrophy. So there's not really large forcing for ascent, but there's certainly forcing for ascent. And so here we are downstream of it, and we will be so for much of the rest of the day and into the evening. The closer the trough axis, perhaps the closer, the more obvious the agiostrophic divergence might be. And I think that gives us a risk for showers. And we're seeing that right here in Iowa in a nice position downstream of the upper trough.
The other thing to note is that given the large wavelength of the flow from the Pacific all the way across the country, it also generally means that it's going to be slowly evolving. It's going to be big changes from day to day. So what we have today, we kind of like what we have tomorrow, and kind of like the day after.
Yeah, that's a very good point. And the other part of that long wavelength pattern is this huge ridge sitting off the west coast. You can't even see the western edge of it on this map. So that's hundreds of miles offshore before you get to that one. So let's go down to the 850 millibar level, Pete, and then I'll be done. So at 850, we have a really complicated but nice. Too bad. If I had a pencil here, I'd draw it a little differently. I'd really accentuate the structure here. But this is a beautiful warm front with our cyclone that we saw on the satellite. And then baroclinicity goes all the way back around to far southwestern Quebec, where all along this baroclinic zone, it's snowing heavily. We'll see that in the surface map. I didn't look at that yet. It's snowing heavily in these locations. And then here's the cold front that's made its way across southern New England, Gulf of Maine, and it's a pretty intense cold front right close to the cyclone anyway, and then it gets a little bit more diffuse as we head to the southern states. But it's cold for this time of year in northern Louisiana, central Alabama, Mississippi, very cold. And we're at -5-ish over us, and at -5 isotherms routinely at this time of year in central Quebec, central Ontario. So this is a couple of standard deviations colder than normal. It was worse earlier in the week. And then here in the eastern U.S., way below normal, probably 2 and 2.5 standard deviations below normal at 850. So very cold over the central and eastern United States this week. That's not surprising. That's not surprising. Given what we've seen. Okay, that's probably it. Let's look at the surface map and see where it's snowing in Canada. Well, I guess there's moderate snow in central Ontario, central Quebec, light snow further to the south and west. It's not snowing in Montreal. It's too warm. It's 41 degrees. You get to go all the way to the northwestern part of the southern portion of the province to get cold enough, I guess. I overestimated how much snow there is. But there is snow in southern Ontario, widespread, most of it light. And there's even a few places in the vicinity of our region where it's snowing, like in North Dakota. It's raining several, the next state southward. And we finally have poked above freezing the first time in, 36 hours or so, close to it. But still chilly with a southerly flow. I think that's all I have for our abbreviated discussion today. Michael, you want to say something about the forecast?
Yeah. I believe, somewhat brief as well.
Okay.
So I guess that rain that we saw, just in the surface map is probably gonna at some point quickly transition over to frozen precipitation as the cyclone begins to exit. It's kind of surprising. I was a little bit surprised as well that we were just seeing liquid precip.
Yeah.
There's an algorithm they use to, this is not explicitly forecast, I don't believe, by the GFS precip type. They have an algorithm to figure out what's the most likely type of precip. Showing a lot of snow out at this time in north and eastern Canada.
Just real quick, Austin Thomas reports from Burlington, Vermont, that they were in the upper 60s yesterday and the front only dragging down into the 40s. Very gusty winds as well, flash flooding as well across Vermont overnight this morning.
Okay, thanks, Austin, for that report. So the sort of current weather map analysis shows this broad area cyclone over the southeastern part of the United States. And you can see, just make out a trough that extends from this low in western Ontario, southward through just west of our state. You can see the trough axis, and then just through eastern Kansas, south central Kansas. And it's along this where we're seeing in the surface map, so we saw some light rain showers here. So this is still liquid precipitation, even though it's so chilly out here. At the beginning of the next surge of cold advection, that's going to start one saying goes through. This band of precipitation goes through the trough axis goes through. So there is a risk we'll see as we look at the forecast as this very weak baroclinic zone transitions through our area for us to get some light precipitation. We're probably cold enough for it to be snow at our location. And then just upstream of it, again, we saw this large scale pattern of northwesterly flow. We'll basically be in that for most of the weekend. So we'll just go ahead, 12 hours to this evening, or early tomorrow morning. This is 1 o'clock tomorrow morning. That front has now crossed our area. You can see the west-northwest geosurface flow over us. There's chilly air over the warm lakes, producing some lake effect rain showers. Because lakes are so warm, it's not going to be cold enough for it to be snow here. But once you move inland just a little bit away from the lakes, cold enough for some light frozen precipitation over northern Michigan. We got a rather quiet pattern with cold advection over us. A broad cyclonic circulation, so that's going to perhaps keep clouds in to some extent. Over the course of the weekend, we can do some, look at some soundings to see if there's much moisture that's going to trap, water vapor trapped in the lower troposphere. But you can see lots of light scattered snow showers forecast by this model at this particular time. This is really a quiet pattern for much of the rest of the country. That old front is well offshore. This is not really a particularly active pattern for us. Let's go ahead to 36 hours of the forecast. So let's jump right to next day. Fronts offshore, a little wave developing along 6 hours of the forecast. So let's jump right to next day. Fronts offshore, a little wave developing along it. That would be exciting for a little bit closer to the coast as this upper trough, thermal trough at least, begins to approach the coast. So maybe some cyclogenesis offshore, but probably going to just miss New England. This is now tomorrow evening. Ridges to our south, winds have gone from northwesterly to now more on the south, or so the southwest. And so more reductions already beginning to start up in this pattern. But again, much of the country is relatively quiet with not much in the way of precipitation. If you go all the way up to Alberta and Saskatchewan to see rain and snow showers at this particular time. But again, very boring pattern in some of it. Let's go to 48 hours, so Sunday morning. That cyclone off the East Coast has continued on out to sea, and you see the fronts associated with it. We're now in even stronger southerly flow, southwesterly flow with warm advection occurring. Again, the air is relatively dry, so we're probably not going to see much in the way of precipitation. It is interesting to note, however, that when you're looking at this, and then looking at the geostrophic surface flow, it looks like there is a small region, perhaps strong localized warm advection, so that might actually force some cloudiness and ascent over us. Okay. But again, pretty weak flow. There's a weak cyclone in southern Saskatchewan at this point, and that'll be probably the next. That will be the next precipitation producer as we see it a little bit forward in time. Let's go to 72 hours. So on Monday, by Monday morning, actually, let's go back to 60 hours. So we'll get to Sunday evening first. with that localized more advection, we had some ascent and a little bit of precipitation. In this case, looks like this forecast is for liquid precipitation as opposed to frozen. We could look at a sounding at this time just to see what the situation is. So if you do a quick on that, please. The profile of temperatures in the lower troposphere. Well,
It's too moist.
yeah, it's moist. It's not enough to get much evaporative cooling, and we're going to be above freezing for at least the lowest, about 50, half a kilometer or so. It's going to be just above freezing. So probably rain or rain mixed with a few snowflakes if we do get any rain showers during that time.
This is the situation at this time of year when we get a lot of infection fog, snow fog. We get humid air from the south. We go foggy, and so I've seen it before where, 20 days out of 30 days in November are absolutely foggy. Pea soup.
That's actually a good
If you
point.
get an
too.
early snow.
Yeah, that's a really good point for this weekend.
Yeah, so with snow on the ground and any warm advection, particularly if it's relatively moist air that's going to affect during that cold sun, you'll perhaps get a lot of, well, maybe fog. So that's something we'll watch out for. So I'll say the weather's boring, but this is going to be, and that could actually impact transportation, air travel, things like that. But otherwise, you might not even consider it. Let's close this out, please. This is the time when the precipitation goes through, and then we still have this wave out to our west. Let's go ahead, get back to 72 hours. And it just falls apart as it approaches us. But when this northwesterly flow, again, we have these changes from day to day. They're slow changes, they're not really abrupt. We're back into even colder air coming in on the horizon on Monday afternoon. With this broad cyclonic circulation, again, these clouds still around us. Let's go to 96 hours. 86 hours, the cold air is firmly in our grips. We have strong northerly flow, cold advection. And again, this is just a very relatively quiet period. Go to 120 hours, we'll eventually get a wave through here. So this is the next wave that comes down from Alberta, so one of these Alberta clippers. At this point, if you look at the forecast, it's going to be passing just to our north, but spreading snow to the northern 2/3 of our state. And will probably be just dry enough, or just far enough south to miss that precipitation, at least initially. But we'll be on the edge of that. That's something certainly to watch, to compare forecasts. We can do that in just a moment. But behind it, it looks like things are going to begin to change a little bit. This really strong cold advection in the lower troposphere. And this cyclone might have a chance to get some legs to it. Let's go to 144 hours. Wow, and there it goes. That's a trough deepen. So that cyclone that was just, a modest one over us moves rapidly to the east and begins to deepen. But this gets cold. This is going to get really cold. In fact, if we look at the temperatures on Thursday morning, over us,
Might be below 20.
yeah,
Wow.
it's the smallest forecasting temperatures below 20 degrees. So this is well below our seasonal temperatures for this time of year. And that purple is just, it's really getting cold. Let's go back to the surface map, and we'll round things out to 168 hours for next Friday, weather watch. Eye keeps on moving, and the warm convection begins out to our west, so, Thursday would probably be the coldest day of the week if this forecast verifies, and then we're back to warming up again. One thing I found really interesting, I like to, can't help but go to 384 hours. Let's just do it. I'm going to forget about the weather that happens in the intervening time period. This might totally ruin it. Let's look at first of all, just the winter weather. Look at the snow depth anomaly. So this is the deviation from our climate anomaly at the very bottom. What I found striking on this, as well as we went through the 6C run for the same time period, huge area of southern Canada is above normal in terms of snow depth. And I wonder just what that's going to suggest for the temperatures over us. The cold air remains to the north. We're going to be on the edge of this boundary between the really truly Arctic air and relatively milder air to the south. Just going to be pretty much at our latitude over the next week or two. And we're going to be developing lots of deeper snowpack if this forecast verifies, which could mean that we stay in this cold regime for much of the upcoming month. So just something to watch out for in there.
Yeah, and more approximately, there's a deficit of an inch or two.
Over us, right?
Yeah, just to our north and west.
Yeah, if we were to go back to the 60s run.
I want to mention that I don't know how much the models have improved in the past decade or two, but they had a heck of a time predicting us to get out of the fog once we get into it.
Okay.
Because in November, the sun is so low that it doesn't create enough turbulence to burn off the fog. And if you wait for fronts, you might never get one that's enough to penetrate down. You have to get a super sinking air system to really clear that fog out. Otherwise, you stay foggy and you can't warm up in between. You can't cool down at night to the cold temperatures,
That's a good point.
but you can't warm up. You just stay real steady.
So based on the series of maps we saw for the surface, once we get that, low level warm advection starting on Saturday night, Sunday, we may get into the fog and stay in it until probably Thursday when we get a strong weather system that goes through a strong cold advection behind it. So,
If that doesn't take away the snow, then you go right back in it.
right.
And the fog in November is just unbelievable around here once it gets going.
That's something I don't think I've actually appreciated. I know it in the springtime,
Yeah.
different warm-ups, but I haven't thought about November. Let's quickly go to this. This is just another map of the snow depth anomaly. And again, there's just two ones. I don't want to make much more of it. You see still less of a deficit, I guess, or less below normal snowfall over Minnesota than we saw in the more recent one. Again, just something to watch that'll be kind of interesting to check out. That just suggests we're going to stay cold. The cold air is going to be toward north. Another way to look at this is you click on the home tab up here and look at the CPC Climate Prediction Center for the next 6 to 10 days or 8 to 14 days. You can see very high likelihood. This isn't, the darker the blue doesn't mean the colder the temperature, it just means the greater probability that we're going to be below normal. And so they're looking at probably at least 80% chance that we're going to be below normal for the next 6 to 10 day period. And then beyond that, it looks like we're going to be below normal. And unfortunately, I'm going to have to take this call because I have a problem with my furnace. So thank you, Greg, for doing this. And of course,
We go back to one map, Pete?
Yeah.
The snowfall map, the snowfall anomaly map? Yeah, I noticed something about
This is from the 60s.
Hudson Bay. Look, this must be climatologically ice-free, so you can't measure a snowfall. But over here, there must be climatological ice by this time, right?
Mhm.
And so presumably, since it's right at the coast, we got a late freeze on the western Hudson Bay, which is interesting. Because that might be one of the features that helps to lock the Hudson Bay low over us once you get snow over the whole water mass. And to the extent that that hasn't happened yet, it may not happen for several days, because this is 384 hours out, that's a contravening effect to keep us from staying cold for the long term. So that's an interesting thing. I never paid much attention to. I just happened to notice it. So
Is that also the Celsius?
I don't know. I bet it is. That's a big area, but let's see.
So you're saying there's less snow than normal up there?
Yeah, so that probably means that there's no ice. So anything that's falling into it just doesn't register as snow, right? So I think this would be the ice shelf climatologically, and there'd be a little bit of snow on it.
Wow.
That's what I'm thinking. I don't know if that's right.
It's also interesting that the Rockies are way more normal.
Yeah, I know.
for this time of year.
After this couple of weeks, it's kind of unusual, isn't it? So, yeah, so that
Western slopes.
signal is the same. So it must be a very large scale almost climate signal.
But they've been getting a lot of easterly flow in the Rockies, so that's probably why they're not up to normal.
Maybe, yeah.
Jet streams been going around them.
Well, that's it, I guess, for today. So next week, we'll come back. We won't have new snow real stories to tell next week, but we will in subsequent Fridays.
We'll have fog stories.
What?
Maybe we'll have fog stories.
Yeah, we could have fog. That's right. That's a really good point. That could be the story of the weekend for the weather is fog.
The Milwaukee Weather Service forecast for next Thursday was high in the 20s.
Is that right?
Yeah.
That's cold. That's really cold for early November. So we've got some interesting things coming up. So thanks, Pete.
All right.
Thank you, Greg, for a great discussion at the beginning. And thanks to Michael, who had to run off and fix his furnace. So we'll see you all next week.
Okay, 1:41, take a break, 10 minutes, quarter after we can start.